What does an isosceles triangle, what does that make it, how does it make it different?
It has two sides that are the same.
Good, two sides that are the same. So I'm going to draw a triangle over here, and I want the two sides to look like they're the same. And if they don't look the same, that's okay, because in math, in geometry, we have these special symbols that show that they are the same. Okay, I'm going to call this triangle A, and then B I'm going to put on the bottom with A, and C kind of at that top. So your triangle ABC, and in an isosceles triangle we have our legs. And our legs are the two sides that are congruent. Okay, so on this one I'm going to say that AC is congruent to CB. And how would I show in that picture, other than just coloring them, that these are the same or they go together? Tick marks, good. So I'm going to do a tick mark here, tick mark here. All right, and so our two legs in this one is side what? How would I name one of those sides? AC and side CB or BC, either way. I heard CB first, so we'll go with that. I'm just going to shade that in a little bit. Okay, now we have our third side, because a triangle has three sides. And with this third side, we call that side the base. So this AB is different. I'm going to use brown for that one. And that's called our base. Base is the different side, or the side length that's different. I don't know. So how do we name that side that's our different side in this one? Side AB, good. With that line above it, because it's a segment. All right, that's how we do this out. That's our vocabulary with sides. Now there's also vocabulary with angles. Okay, so as I'm going to just do a line across here so that I remind myself that's kind of the same, kind of different. We're going to keep looking at the same picture. But in this picture, there's two types of angles. There's a vertex angle. And if we think of vertex, what does vertex usually mean? We saw it last year with like parabolas, absolute value graphs. What did you say, Dave? Were you going to say something?
Oh.
No? What do you got, Ty?
The Middle.
Yeah, the middle, kind of like where it goes up or where it goes down. Good. So our vertex angle is the angle where the legs meet. Excuse me. All right, and then this one, where is the angle that the legs meet, where they come together? Is it angle A, angle B, or angle C? Good. Angle C is where those two legs come together. It happens that the vertex in this one is at the top of our triangle because of the way we drew it. But it won't always be at the top. It's just wherever those two congruent sides come together. So our vertex angle is angle C. Our other angles are called base angles, and that's a really important word. We're going to use that a lot today. Really, that's all what this has been building up to is base angles. But to know base angles, you need to know what a base is. And to know what a base is, you need to know what legs are. It's a whole thing. Our base angles are the two angles attached to the base. The two angles attached to the base. So as I look at my base here, pretty much what I'm looking for is the angles at each end of the base. So what's one of the angles at one of the ends of our brown base here? B and A, yeah. So we have this angle and this angle here. These are both our base angles. Okay, so angle A and angle B. So every isosceles triangle has two base angles, one vertex angle. All right, we have two theorems. There's a lot of writing in this one. Sorry, I kind of forgot how much writing there was in this. We don't have that much writing tomorrow. That's nice. Our last day have a lot of writing. We have two theorems that are really important when we talk about isosceles triangles. So our first one is the isosceles triangle theorem. And our isosceles triangle theorem says if two sides of a triangle are congruent, I'm going to just say if two sides are congruent. Can we assume that we're talking about a triangle? Is that okay? Just so we don't have to write so much? Okay. Because it's the triangle theorem, so we're obviously talking about a triangle, right? Okay, so if two sides are congruent, then the angles opposite of them are congruent. Okay, so when we look at our triangles, anytime we have an isosceles triangle where two sides are the same, it's guaranteed that two angles will be the same. So that's another way to tell an isosceles triangle. If you see a triangle that have two sides that are the same, you know instantly that two angles will also be the same. It's always the case. So in this case, when you look at this, I'm going to go back up to our picture for a moment. When I look at triangle ABC, which two sides are the same? AB is not, no. Sides are the same are AC and CB. So what are the angles opposite of those sides? And when we say opposite, we're thinking like we go through the triangle. We go opposite of those legs. So opposite of CB is angle A. And what's opposite of CA? B. So really we're talking about which angles in that triangle. We're talking about A and B, and what do we know about those angles? What kind of angles are they? Congruent, and we call them base angles. There we go, they're base angles. So when we talk about this one here, really what we're saying is we're saying that the base angles are congruent. All right, our second theorem comes into play right after this. We're going to just reverse it. We're going to do the isosceles triangle converse. All right, when we do the isosceles triangle converse, we're going to think back to chapter 2b. Chapter 2a, sorry. Way back here. Converse. What is a converse?
It's not the shoe brand, just so you guys know. It's the
Good. Not quite. We didn't use the word opposite because opposite was like inverse. We take the original A, then B, and how does it change? Switch places. Good. It goes B and then A. So we're not doing opposites. We're doing our switching places. We're moving things around, kind of like Converse. You walk around. It's a skater shoe. You move around, so we switch places. So when we do this one, isosceles triangle converse, we're actually going to start with which part? We're taking this original theorem. If two sides are congruent, then the angles opposite of them are congruent. So what are we actually going to start with this time? What's our ending of the last one? Good. And we don't know what them is yet, so we're just going to say if two angles are congruent. If two angles are congruent, then what can we assume about the sides? Yeah, the two sides opposite of them are congruent. And what do we call the two sides of the triangle that are congruent? Legs. So really here we're talking about our legs are congruent. All right, we're just going to do 2 examples today. One is going to be an example where we draw a picture and we just find the answer. And then our second example is going to be a proof. How amazing. So exciting. Love it, love it, love it. Amazing. All right, so for our first example here, we're going to draw a picture. So for our picture, I'm going to have kind of this obtuse angle to start with. So draw a nice big, maybe like 108 degrees, maybe. And then we'll connect that, make that triangle. All right, this time we have D, E, and F at the top. All right, we know that F, I don't really have enough room to write in there, so I'm going to just do like one of these little arrows that says that that is 28 degrees. And then we also know that FD is congruent to DE. What I want to find is what is the measure of angle D, and I want to know what is the measure of angle E. I want to know what are those other 2 measures in the triangle. All right, so when we look at this triangle, what type of triangle do we have? What do we know about it? If there's obtuse, what else do we know? What? 28 degrees. There's tick marks. Good. And what do those tick marks tell us? Those sides are congruent. So I know that this side, DF, is congruent to DE. What do we call those sides that are congruent? Legs, which means this other side is the base. And in an isosceles triangle, if we know the legs are congruent, that tells us which other angles are congruent. The base angles, good. So base angles, remember we just follow that base. We go to like one side of the base, we go to the other side of the base. So what's one angle on one side of the base? F. So we know F will be congruent to E. Those are our base angles. Those are the same. So without thinking too hard, we know E is 28 degrees. Easy peasy. Now, we need to go back and we need to find angle D. Angle D is the vertex angle. It's different than the other 2. So if I know 2 of my angles of a triangle, how can I find my last angle? Subtracting from what? 180, good. So we can do 180 minus what? Minus 28, just one of them? Minus 2 of them, so minus 28, minus 28. Some people, you might have done that 28 and 28 together first and gotten 56, and then done 180 minus 56. I apparently don't have my calculator back here, so someone's got to help me with this. $124? So we got 2, Zach? No? Okay. 124. So angle D is 124 degrees. All right, now, if this would have been backwards, what if we knew angle D you guys actually did this back in 4.1, you didn't, or in 4.2. You didn't know it was this theorem. But if I knew angle D, and I know these two sides are congruent, how could I find these two sides based on 124?
Do the minus
Mhm.
180.
Minus 180, we would get 56, and divide by 2. Good. All right, number 2, we're going to do a flow proof. I only have like 3 lines here, so I'm going to go to my next page. Because the flow proof takes up a lot of space because it is arrows. And I like arrows. I like flow proofs. They make me happy. Happy, happy, happy. All right, so in number 3, not 3, 2. Sorry, I'm skipping one from last year, so it looks like number 3 to me, but really it's going to be number 2. All right, in number 2, we're going to have this lovely, handy-dandy picture. And in our picture, we're going to kind of create like an X. But for our X, we're going to have like a really big side of the triangle, so the X happens really early. And then it gets really big. So kind of small side, big side.
I'm drawing a fish.
If you can. If not, that's okay. Alright, and we'll make those into triangles. So do one line, yep. And then the other line's going to cut it sooner than later. Closer to the beginning. Have that intersection. There you go. Alright, and then we're going to connect those into triangles. Alright, let's label those points first so that when we talk about those triangles, we know what points we're talking about. We have that angle A is here. We have B. C is in the middle. And we're going to actually go all the way out to D here, over here. And then we have E is here. All right, things that we know. I'm going to use one color to show the parts that were given to us, because as we work, we'll probably add to this picture. So I'm going to use one color to show the parts that we know. I'm going to just mark it on the picture rather than doing a given. Okay. And what we know is that AC is congruent to BC. Oh, we're going to do a flow proof though. All right, and I know that angle A is 69 degrees. Again, I wrote mine too small to actually fit 69 in there nicely, so doing that little arrow. And we know angle D is 42 degrees. So that's all the information we know that we are given. And what we are going to try to prove here is that CE, segment CE, is congruent to segment DE. Alright, and I was thinking we could do a flow proof. Is that alright with you guys? Get one more practice in with those? Tomorrow we can do a 2-column, or do you want to do a 2-column today and a flow proof tomorrow? What makes sense to you? Does it matter? Okay, let's do our flow proof. So to start off with, we're going to start with our given. And since I just started a new page, I'm going to do my whole flow proof down here because then I can just take up the whole page. It's going to be great. All right, what part of this information from our picture do we know? Measure of angle A is 69 degrees. Good. Once we write it, we put a box around it, and then underneath it, we write our reason. It was given to us in the picture. There wasn't an actual given this time. But we can always use a picture for a given. What else do we know? Good, angle D. I'm going to actually put that a little bit closer to the side here. Measure of angle D is 42 degrees. And again, that's given. Good. AC is congruent to CB. I'm going to throw that one in the middle. Then that way when we do it, we just don't... It's okay if your arrows cross over in a flow proof. That's the idea of a flow proof, is you can have your arrows go any direction you want. But we are going to give it a moment there. Alright, so based on what we know, if I have two sides of a triangle that are congruent, what does that tell me about my two angles? They're congruent. So in this first triangle, if I look at ABC, I know AC is congruent to CB. So which two angles would they be the same? Would it be AB, BC, or CA?
AB.
Good. The ones across from it, so across from this one we have B, across from this one we have A. So we know that A and B should be the same. So that comes from this idea. And we could write that out if we were doing a two-column proof. We'd probably have to write angle A is congruent to angle B and then go through all of that. But we know that they're the same. So what is angle A?
69 degrees.
So what is angle B?
69 degrees.
Okay, so since the sides were congruent, we knew that these angles would be congruent. And since this is 69, this is also 69. So it comes from both of those ideas. Alright, now as I go back, is that my Isosceles triangle theorem? Or is it the converse? What did we start with? Did we start with two sides are congruent or two angles that were congruent? Sides. So that's just our Isosceles triangle theorem. So underneath this, I'm going to just write Isos, I-S-O-S for Isosceles triangle theorem. All right, if I go back to my picture, angle B is now 69 degrees. So what can I find after that? Angle C. How can I find angle C?
69 or 180 minus 69.
Good. Yeah, we do 180, because the 180 is the whole thing, minus our two angles, so minus 69, minus 69. Samaya, you got that for us in a calculator? Or someone on a calculator? .42, good. So measure of angle C is 42 degrees. That's good. That means I did this right. Yay. Okay, and we know measure of angle C is 42 degrees because we know all three angles have to add up to what?
180.
180. So that's called our triangle angle sum theorem. And I'm just drawing a triangle instead of writing out the word triangle because I'm lazy. Or efficient is how you could look at that. Alright, once we get that written down, I'm going to go back to my picture. I'm using blue again because this is not what was given to me. This is part of what we found out. Angle C is now 42 degrees. Oh no. We couldn't just say angle C. Why can't we just say angle C? How many angles are there at C? 2. Technically 4 if you count the top and the bottom. So we should use 3 letters there for C. So if I want to talk about this C on the left side, what 3 letters should I have used? Good. A, C, B, or B, C, A. So measure of angle B, C, A. Alright. My bad. Sorry. Should have realized that before, but I got too excited. I just love fill proofs. Alright, we're almost there. You guys are crushing this. Alright, we know that BCA is 42 degrees. So when I look at my picture, what does that tell me now if this is 42 degrees? Good. When we go across from it, the angle across has to be the same. What do we call that, the angle across? Vertical. Good. So we know angle C has to be 42 degrees. But we can't just call it C, as Tyke mentioned. Good. Let's do DCE. So measure of angle DCE. Well, this is going to take up like a whole page. DCE is 42 degrees. And we knew that because from this last one was 42, we know this is 42. Because what type of angles were created? Vertical angles. But now as I look back at my picture and I look at this triangle, now I'm only going to look at this CDE triangle. What do you notice about those 2 angles that we have? They're equal. Yeah. What is another word for equal? Congruent. So down here we're going to say that they're congruent. So over here I know this is 42 degrees. So angle DCE is congruent to... What was our other angle in that triangle? Yeah, just angle D, because there's only one angle there, so we can just take angle D. And we got that way back from our given. Finally using that little fact there. And how did we know that they were congruent? Yeah, they're the same. That's our definition of congruent angles. Ooh, this one took longer than I remembered. Sorry. All right, last step. Holy cow. All right, we have 2 angles that are congruent, which means what type of triangle are we dealing with? An isosceles triangles, because isosceles triangles always have 2 angles that are congruent. We know 2 angles are congruent, so now we can say the 2 sides are congruent. Our base angles are congruent, 42 and 42. So we want to look across from those angles. So across from angle D is which side? CE, that whole side, C to E. What's across from this angle 42?
DE.
Yeah, DE. Is that what we were trying to prove? Is that CE is the same as DE?
Yeah.
Yep. Give me 2 more seconds. I have one more thing. All right, and is that going to be our theorem or our converse?
Here, our converse.
Converse. Good, because did we start with the sides or did we start the angles?
Angle.
Angles and then sides. So this is our isosceles triangle converse. Hey, we did it. It took up a whole page. But we did it.